Welcome to Maths with Parul. This paper is a continuation of the previous videos made. It's January 2019, paper 1, syllabus B, Pearson O-levels. Let's begin. So we're continuing with question 22. Here they say the width of a rectangle is x meters. As you can see, I have drawn the width and rectangle here and written the width as x. The length is 7 meters longer than the width, so that would be x plus 7. Then they say find the set of values for which the area is less than 44. Now how do you find the area of a rectangle? It's the length into the breadth or width, so we have x into x plus 7, which is x squared plus 7x. Now they say it's less than 44. So here we have the area less than 44. Area is x squared plus 7x, that's less than 44. You bring everything to one side and you have x squared plus 7x minus 44 less than 0. Then we say let y be equal to this expression, and I'm going to factorize the expression, and I get y is equal to x plus 11 into x minus 4. Now I do that because that's how we solve inequalities. We make sure that we have the inequality and 0 on the right hand side, and then we rewrite the entire expression as y, and we try to sketch the graph. So how do we sketch the graph of y equals x squared plus 7x minus 44? We follow the usual rules. We look at the shape of the graph. Because the number in front of x squared is positive, it's going to be a u-shaped graph. So we know that already. And then we look at when x is equal to 0, what is y? So if x is equal to 0, y is equal to minus 44. When y is equal to 0, we simply equate this to 0, and then we have to solve these two brackets. So if we equate this to 0, we'll find that x, if we solve this, we have x plus 11 equals 0, or we have x minus 4 equals 0, and when you solve that, you get that x is equal to minus 11 or x is equal to 4. So now I have the points here, which is essentially when y is 0, x is 0, y is minus 44. When y is 0, x is minus 11 or 4. And I know the shape of the graph is U-shaped, so I sketch the graph. Now I'm going to look at the inequality that they have asked us to find. When is y negative? Well, y is negative from minus 11 to 4. However, y is basically the whole area, which we cannot have it as any length cannot be negative. So therefore, when y is 0, x is between minus 11 and 4, but x is a length and x cannot be negative. So we can only consider the values which are positive, that is from 0 to 4. So our answer is x greater than 0, less than 4. So for this question, you should have a thorough understanding of firstly how to set up a rectangle and find its area, how to write the inequality, how to sketch the inequality, and once you sketch the inequality and get the set of values, how to actually answer the question, because we can't blindly say that x is between minus 11 and 4 since x cannot be negative. So all those factors have to be thought out carefully. Let's move on now to the next question, and we're going to look at question 24. Now if you look at question 24, they have given us a reciprocal graph. The function is 4 plus 3 over x. The first part of the question A is to find f of 2. That's easy enough. We simply substitute 2 in the function. So we have 4 plus 3 over 2, which is 5.5. Then they ask us to find the range of f. Now, if you look at a reciprocal graph, it's going to be, since x is positive, it's going to be here. But this is not just a reciprocal graph, it's 4 plus the reciprocal graph. That means the entire asymptote goes up to 4. So our graph is like this, and the minimum value is going to be 4. So if you look at the range of f, it's always going to be greater than 4. That answers part A and B. Now let's look at part C. They say express the inverse function. For inverse functions, there are 4 steps. First, we let y be equal to the function. So y is equal to 4 plus 3 over x. Then our step 2 is we interchange x and y. So x is equal to 4 plus 3 over y. Then our step 3 is we solve for y. So we take 4 to the other side. X minus 4 equals 3 over y. We cross multiply. Y into x minus 4 equals 3. Then we divide by x minus 4. Y is equal to 3 over x minus 4. Now that is our step 3. And what is f inverse? F inverse is y. So our f inverse function is 3 over x minus 4. That answers part 3. Then let's look at part D, which is the function g is defined by g of x is equal to 4 minus x over 5. And what do we have here? We have that express the composite function f of g. Now, how do we express composite functions f of g? F of g of x is equal to, what is g of x? 4x minus 5. So I write f of 4x minus 5. Now, I know that f of x is 4 plus 3 over x. So wherever I have an x, I replace it by 4x minus 5. Now I'm going to this is just an algebraic fraction. I put it under common denominator of 4x minus 5. So I have 4 into 4x minus 5 plus 3. If I expand the numerator, I get 16x minus 20 plus 3. 16x minus 20 plus 3 is 16x minus 17 over 4x minus 5. And that is my answer for f of g of x. Let's move on to the next question, 25. Here they have given us the volume of a pyramid. So here the diagram shows a pyramid and they're asking us the volume of the pyramid. Now how do we find the volume of a pyramid? It is 1/3 base area into height. So we want to find the area of the base. The area of the base is AOC and we want to find the height, which is given, and that's 12. Now how do we find the area of the base? So the area of the base, they've already told us that AO is perpendicular to OC. So area of OAC is the area of a triangle, which is half of base into height. Okay, so the base is 7. The height is, we can say 5. So it's 7 into 5 over 2. And that's the area of OAC. So here we have that the area of, they want the volume. So we'll start off with first the area OAC over 3 into 12. So now here what we have is, we have OAC, which is base into height over 2, where base is 7 and the height is 5. Now remember that 12 over 3 is 4, so we write 4 there, and then we write 7 into 5 over 2, and then when we calculate it all, we get 70 centimeter cubed. That's the volume of the pyramid. Now let's move on to the next part of the question. They say find the area of triangle ABC. Now, to find the area of triangle ABC, we can use the formula AB sine C over 2 because we don't really have a base or a height. Now, AB sine C, this is A and this is B and this is sine of C. Now let's have a look at the information that we do have. All right, so we know from this that A, simple A, is the hypotenuse of this right angle triangle. And in this right angle triangle, you have 12 and you have 5. So we can use BC squared is equal to 12 squared plus 5 squared, and the square root of that will give us 13. So we know straight away that A is 13. Then we want to find out AC. Now, to find AC, we know that if you look at this triangle AOC, AC is the hypotenuse of AOC. So again, we can use Pythagoras theorem and say AC squared is equal to 7 squared plus 5 squared, and so, which is 74, and AC is the square root of 74. So here I can replace B by the square root of 74. Then we have to find out sine of C over 2. Now to find sine C, we have to use the cosine rule for non-right angled triangles. So we want to find out this angle. We have got 13, we have got root of 74, but we don't have AB. So AB we're going to find because we have another right angle triangle here of 12 and 7. So AB squared is equal to 7 squared plus 12 squared, which is 193. So AB is the square root of 193. So when you have 3 sides in a triangle, we can find the angle. So here we're using the cosine rule. We have a squared, cosine of C is a squared plus b squared minus c squared over 2ab. A squared is 169, b squared is 74, c squared is 193. So 169 plus 74 minus 193 divided by 2ab, which is 2 into 13 into square root of 74. We end up with 0.22355, and cosine inverse of that gives us 77.082 degrees. Now we use that to write sine of 77.082 degrees. And when you multiply that with root of 74 and times 13 divided by 2, we end up with 54.5 centimeters squared. And that is the area of this triangle ABC. I hope you understand what I have explained in this question. In this part, it's slightly complicated because we do have to have a thorough knowledge of Pythagoras theorem. We also have to have a thorough knowledge of finding the area of a triangle for non-right angle triangles, and we have to know how to apply the cosine rule for non-right angle triangles. But that's all for now. Until my next video, thank you for watching.